Quantum physics is a branch of physics that deals with the behavior of matter and energy at a very small scale. It focuses on the subatomic level, studying particles like electrons, protons, and photons. The first thing to understand about quantum physics is that it's different from classical physics, which deals with the behavior of matter and energy at a larger scale. In classical physics, everything has a precise location and speed, and we can predict how things will behave. But in quantum physics, things behave differently. Particles can be in multiple places at the same time, and we can only predict where they are most likely to be. This is because in quantum physics, things don't have a definite position until they're observed or measured. One of the key concepts in quantum physics is wave-particle duality. This means that particles can behave like waves and waves can behave like particles. For example, light can act like a wave, but when we try to measure it, it behaves like a particle. This is known as the wave-particle duality. Another important concept in quantum physics is superposition. This refers to the idea that particles can exist in multiple states at the same time. For example, an electron can be in two different energy states simultaneously. This is important for understanding the behavior of atoms and molecules. One of the strangest concepts in quantum physics is quantum entanglement. This is a phenomenon where two particles can become correlated in such a way that the state of one particle is dependent on the state of the other, even if they are separated by great distances. It's like having two spinning tops that always spin in opposite directions, no matter how far apart they are. In quantum physics, we describe the behavior of particles using probability functions. This means that instead of saying where a particle is, we describe the probability of finding it in a certain place. Think of it like rolling a dice. You don't know which number will come up, but you can predict the probability of each number. Quantum physics has led to many technological advancements, including the development of computers and other electronic devices. These devices use the properties of quantum physics to store and process information. One important application of quantum physics is in quantum computing. A quantum computer uses quantum bits, or qubits, to store and process information. Unlike classical computers, which use bits that can only be either 0 or 1, qubits can be in multiple states at the same time. This allows quantum computers to solve problems that classical computers cannot, such as breaking encryption codes. Another application of quantum physics is in quantum cryptography. This is a method of secure communication that uses the properties of quantum mechanics to ensure the privacy of communication. It's based on the principle that any attempt to measure a quantum system will disturb it. So if someone tries to eavesdrop on a quantum communication, the disturbance will be detected and the communication will be disrupted. In summary, quantum physics is a fascinating field that challenges our understanding of the physical world. In quantum physics, particles can be in multiple places at the same time. Their behavior is described by probability functions, and they sometimes act like waves and sometimes like particles. Quantum entanglement is a strange phenomenon where two particles affect each other's behavior, no matter how far apart they are. Quantum computing and quantum cryptography are just two of the many applications of quantum physics that are changing the way we think about technology and communication.